Good afternoon, everybody. What I'm going to do is give you a very quick video voice review on the notes from our most recent class, whether or not if you have me on red day or black day. Now, first thing we talked about was distance between 2 points. Take the absolute value. It will be positive. So even if you walk either from left to right or right to left, the overall distance is positive, because think about if you're driving. You do not drive negative miles. So what we did was differentiated between ST, which is your line segment, and then when they say ST, that's distance between S and T, the points. Now in this case, found out that S is at -5, T is at -2. All we really do is count. So you count 1, 2, 3. Now, some of you were saying, okay, why is it not -3? Because again, distance, it's always positive when we're dealing with distance because absolute value. So we just look at how many spaces or how many miles we walked. Now, similarly, UV is 1, 2, 3, 4, 5 steps. So UV is 5. So that was for the second problem. And overall, from S to V, 3, from S to T, plus another 4, T to U, and another 5 from U to V. So 3 plus 4 plus 5 is 12. Another way we did it, 7 minus -5 for absolute values, signs, and then of course minus negative becomes a positive. So it's really 7 plus 5, which is 12. And absolute value of 12 is 12. Now, segment addition postulate. So if A, B, C are on the same line, and if we know the distance from A to B, we add it to the distance from A to C, the overall sum is the entire distance from A to C. So first example, AB is 3, BC 5. We need to find out AC. So AC is 3 plus 5, which is 8. Now, there's also, in this diagram, the second one, we needed to figure out what was AB given AC and BC. So AB we didn't know yet, but we knew that BC was 10, that was given to us, and then AC, entire distance, 14. So now what we needed to do was solve for AB. And that's basically 14 minus 10. And then of course, don't forget, 10s go away. And then we're just left with AB. 14 minus 10, 4. Do the same thing for number 3. AB was given to us, 6 plus BC. We didn't know that yet. And then AC, which is 12. So also notice, again, whenever you see the same letter come up more than once, that's your point. So it could be the midpoint, it might just be a regular point, somewhere between your two endpoints. In this case, we have 6 plus BC equals 12, because AB gets replaced with 6. BC, we don't know yet, and then AC, the entire distance, 12. So we subtract 6 on both sides. BC equals 12 minus 6, or 6. That's this part right here. Now, the next problem was we're going to use the segment addition postulate as we have not only larger lines, but expressions that are represented for the line segment. So what happened was EF, in this first example, EF I'll use a Actually, I'll use a highlighter for this. So EF is this distance, and EF is represented by the expression 8x minus 14, and then we add it to FG. FG turns out to be 4x plus 1. So now we look at our expression, 8x minus 14 plus 4x plus 1. It's on the left side of the equal sign. Now, best thing to do, always before you bring terms to the left or right, look at one side of your equation. Look at the expression, see if you can simplify. In this case, we can. We can simplify 8x plus 4x. That gives us the 12x. And then you have your negative 14 plus 1. And that gives us negative 13. So now we have a two-step equation. 12x minus 13 equals 59. So the goal is to isolate. Just want to do something real quick. We want to isolate our variable. That is the ultimate goal. So we first add 13 to both sides. Let me make that up. So 59 plus 13 is 72. And of course, the negative 13 with the positive 13, they knock each other out. So we're left with 12x. Is this 12x? Or down for the red. It's 59 plus 13, 72. Now, 12 times x, opposite of multiplying by 12, is dividing by 12. And we do that to both sides of the equation. So 12x divided by 12, left with x. And 72 divided by 12, we're left with 6. Now, once we find our value, we substitute 6 into the two expressions. So for EF, substitute 6 for x. So we're left with 8 times 6 minus 14. 48 minus 14, 34. Similarly, 4 times x plus 1. So 4 times 6, 24, plus 1, 25. Now, good rule. Always check to make sure your two sides equal. So does 34 plus 25 equal 59? Answer is yes. Now, looking at our second problem, similar. PQ plus QR equals PR. Well, PQ is 4x plus 6. QR, 7x plus 15. So what we need to do is combine like terms like before. 4x and 7x, 11x, 6 and 15, 21. So you have 11x plus 21 equals 120. So isolate our variable just like before. We need to get the x by its lonesome. So first we subtract 21 on both sides. So we get 99 on the right side, 11x on the left. Then we need to divide both sides by 11 because we're multiplying x times 11, opposite of multiplication. We divide by 11. So this x is what we're trying to isolate in the end, which after, so basically whatever operation you see featured here, to solve for the variable, you work in reverse order. So we see that 11x plus 21 is 120. Oh, I see we're adding, but opposite of adding, subtract. Then your next step, 11x equals 99. Since we're multiplying by 11, opposite of multiplying, divide. So divide both sides by 11, bang, x equals 9. Now, just like before, you need to substitute 9 for x. That's what you need to do for both expressions, for PQ, which is 4x plus 6, and QR, 7x plus 15. So now you substitute 9 for x. So for PQ, it is 4 times 9, whoa, 4 times 9 plus 6, or 36 plus 6, which gives us 42. So that's one value. Now, you also have to substitute 9 for the x for QR, which is 7x plus 15. So 9 is replaced in the x, 7 times 9, 63. Add 15 more, you get 78. So then you add these two values to get your overall total of 120. Always check to make sure that's the case. And indeed, this works. This part right here, now I did talk about this for one of the classes, where two segments, same length, like A to M, M to B, congruent. Symbol, equal sign with a little twiddle, tilde mark, that's congruent. It means is equal to. Some of you might say is similar to. I'm good. Now, congruence is noted on segmented diagrams with vertical hash marks or check marks. For the most part, you'll see one. Sometimes you'll see two. Let's differentiate which segments are congruent to each other. Now, very important, bisect a segment. You are splitting it right into two equal smaller segments. And the midpoint, that's the point that divides the segment into two congruent smaller segments. So in this case, M is your midpoint. It is splitting up the segment from A to B into A to M, then M to B. And then point, line, ray, or other segment intersecting a segment is the segment bisector. So in this case, point M is your segment bisector, right in the middle. All right, so working with angle bisectors and everything, let's talk about some of the problems. Now, we did some of these in class. We might not have done them all. So for problem number 3, this Q is the midpoint of PR. So we need to find PQ, QR, and PR. Now, since Q is the midpoint, that automatically means the segment from P to Q has the same value as the segment from Q to R. So given they're the midpoint, those two expressions should be equal to each other because distance is exactly the same. So you would set up the following equation. Set up 6x minus 7, and you will set that equal to 5x minus 1. Now, most of us were taught, look for the bigger variable or coefficient. Leave the bigger coefficient term where it is. Looking for the smaller coefficient. You're going to move that to the other side of the equal sign. So in this case, 6x minus 7 equals 5x plus 1. And you could have flipped it. That's fine too. Then you would just bring the 5x to the other side of the equal sign. So we have 6x minus 5x minus 7 equals 5x minus 5x plus 1. So at this point, to figure it out, you subtract 5x on both sides, because that's the goal. We want to get x by itself. So 5x minus 5, those go away. And you have 6x minus 5x, which some of you might write 1x, but you don't need the 1. So x minus 7 equals 1. Add 7 to both sides. There you go, x is 8. Now once you get your value of 8, you will plug it into each value of x. So in this case, 6 times 8 minus 7. 6 times 8 is 48, minus 7, 41. Similarly, 5x plus 1, 5 times 8, 40. Plus another one, 41. So yes, Q is definitely the midpoint, because each side is the same amount, distance-wise. And then when you add up your 41 plus your 41, 82 is the total. Now, problem 4 is similar to problem 3. Turns out U is your midpoint. And we see that TU is congruent to UV, so you could set TU equal to UV. In this case, 8x plus 11 equals 12x minus 1. So now for this problem, we decided 8x usually is variable term on the left is usually larger, but in this case, the variable term on the right's large. So we're going to move this 8x. Oops, I forgot my line. To across the equal sign. We're going to move that to the opposite of adding 8x is subtracting 8x. So 8x minus 8x, that goes away. 12x minus 8x, we have a 4x. And therefore, the 1, So 11 equals 4x minus 1. So I'm going to get there first. Let me clean that up. So 1 comes on down. So now, next step, we have to move -1. So we do that by adding 1 to both sides. Of course, this term goes away. 11, which came down from the top, plus 1 gives us 12. And after we subtract 12x minus 8x, this 4x just comes on down for the ride. Last but not least, divide both sides by 4. 3 equals x. And you plug in 3 into both the expression. Now always use parentheses. 8x plus 11, 12x minus 1. You should get the same result. It's our order of operations. So for instance, 8 times 3, 24, plus 11, 35. And 12x minus 1, 12 times 3, 36, minus 1, 35. Then for TV, you need to add up T to U plus U to V. So this whole section is TV. So TV equals 35 plus 35, or 70. All right. Now we did this first one in class. AD is 20. AC is 34. Find the value of x. And find AC and DC. Well, look at your diagram. They said AD was 20 since this point D is bisecting this segment. Then what you do next is 20 for AD. Now they tell us to find x if AC, DC. Well, this problem we have to work backwards, because since D is your midpoint, we know AD has to be 20. Therefore, DC, since they also have the same hash marks, is also 20. So right away, DC equals 20. That was given to us. Well, I shouldn't say given to us. It was able to be found without doing any math. Similarly, you could say the same for AC. So AD is 20, DC is 20, 20 plus 20, 40. So AC is really 40. So now we're not finished because we need to solve for x, which it's not going to be so bad. We see AC equals 3x plus 4. Now, AC we found out was 40 due to the diagram. So we replace AC with 40. So you have 40 equals 3x plus 4. When you do that, cross out positive 4, negative 4. 40 minus 4. That becomes 36. 3x. Hit that for the right. So we have 36 equals 3x. Then, last step, divide both sides. 36 and 3x by 3. So then, of course, the 3's go disappear. 36 divided by 3 is 12. So some of us might have wrote 12 equals x. So 12 equals x or x equals 12. Either way is the same. Think about the equal sign as a revolving door or a mirror. You can flip it. So then we have x is 12, AC is 40, DC 20. Now for the last problem, we started it a little bit, I think for one of our periods. If not, what will happen here? ED is 5y plus 6, dB y plus 30. So we need to find the value of y. Then it's ED, dB, EB. Now, look at our diagram. It turns out ED and dB have the same length because the D, that point D that's right in the middle, is your bisector, your segment bisector in this case. So it turns out ED is this portion here, and then dB, this part right here. But it turns out they're the same. So ED and dB, I'm going to use a different color for, actually I'm going to use a different color for all of them. So ED, I'm going to mark it in green. And then dB, I'm going to mark in blue. So since ED and dB have the same number of hash marks, D is the midpoint. We could say 5y plus 6, which is this distance, is exactly equal to y plus 30, which is this distance. So now, once you set up your 5y plus 6 equals y plus 30, you solve for y. Step 1, subtract y on both sides. 5y minus y, you get 4y. And then this y over here minus this other y, they cancel out. So they're gone. Next, you subtract 6 from both sides. Because remember, you want variables on one side, non-variables on the other. Usually look for the lower variable to move. So in this case, we're going to move the y from the right to the left side. But opposite of adding one, you subtract y. So that's what's going on here. Then subtract 6 on both sides. So after we subtracted 5y minus y, 4y, this plus 6 comes down, but then we subtract it on both sides. 30 minus 6, 24. So then, besides those y's going away, the 6's go away, positive negative 6. So we wind up with 4y equals 24. Now the goal, get y by itself. So we're looking only for the y. So 4 times y, opposite of multiplying by 4, dividing by 4. So positive 4 and negative 4 go away. So then y comes on down for the ride. 24 divided by 4, 6. So now last step, we substitute 6 for both expressions, 5y plus 6, y plus 30. And it turns out, we'll do the y plus 30 first because all you have to do is just add 6 plus 30, 36. Now, so that's for dB. Now, dB and ED are the same exact measurement. So since they are congruent, same measure. So if dB is 30, ED should also be 30. Check for, make sure it's true. So replace the y with 6. It's 5 times 6, 30. Add 6, 36. Now your last part. So we found y, ED, dB, and now EB, which is ED 36 plus dB, another 36. Grand total, EB 72. So hopefully this video will help as we progress to the next section, which we will talk about angles, angle measurements, and similarly, angle bisectors. So thank you very much, and enjoy. See you again very soon.